Today we're going to discuss about one of the best topic of the current technological world, and this technological world is covering a lot of other technologies, right? The topic which we are covering is connected with couple of other recent technologies also. The one which is one of the favorite topic of mine as well, which connects other particular domains and where you get couple of liberty to deal with going with the innovations. So today we're going to discuss a lot related to the topic called computer vision. So now I'm starting with a topic, right? People used to talk about computer vision as one of the I for AI, artificial intelligence. And you can imagine artificial intelligence, lot of developments in artificial intelligence because of this computer vision itself. So there are if you'll start from data, right? So data could be categorized in three different terms. Either you could find this data in terms of text, right? In terms of files, right? Where you have alphanumerical data, right? And the other part of data could be your voice or audio, right? The last and very significant one is vision or visual data, that is through images or videos, right? So we are talking about the third one. As per human reception of a data, right? We have senses, five senses, right? Out of these five senses, we used to capture 83%, maybe more than 83% of data in our human body, in human brain, through our visual memories only, right? From a visual perspective only. So from your eyes, you used to capture 83% of a data, of a total data that goes to your brain, right? So we are talking about 83% of the total data category, and that is to driven with computer vision, right? So we are giving a vision to a computer, one of the finest and smartest device available right now in the world. So let us understand how will be going further, proceeding further with this topic, and what kind of topics that will capture in this masterclass. So let me go through with you the agenda today. The agenda for today will be discussing about computer vision, what is this, and number of use cases in computer vision related to AI. Artificial intelligence is going in all over the sectors. In recent times, you might have seen AI development going with agriculture, maybe medical science, maybe in automations, right? In many different areas. So we'll be talking about those particular areas and the recent inventions or the product developed inside those domains also, right? Then we'll understand how it works and what is the purpose basically of using those inside technologies, basically working behind this computer vision. We'll also connect this computer vision with deep learning. Deep learning is one of the other domain inside this artificial intelligence, which is a part of data science itself, right? So we'll understand whether how computer vision can be linked with deep learning, and how these two fields connecting together can make a huge difference in the market, right? Then we'll see whether do we have some models or algorithms based on computer vision working for object detection as well, or various object recognitions. The main purpose of your eyes used to, you used to use your eyes just to recognize a lot of objects, and those objects are actually being taught by many different peoples, right? So let us see how we can actually capture those objects, capture those images, and we can extract the meaningful information from those basically images or videos, so that those information could be used for further purpose. We'll also understand computer vision applications in different areas. Then we'll also understand what are the real challenges that right now the scientists or developers are facing up in computer vision. There are a lot of challenges. and because of this challenge only we have a liberty, or we have options, we have opportunity, we have lots of opportunity in fact right now, that to work or get maximum outcomes from computer vision. Maybe this is one of the technology which will lie in in next couple of decades also. So if you'll start working with computer vision, I'm sure there are lot to come, there are lot to come, there are lot of opportunities to build up some good products or projects basically in upcoming years, right? So it gives you a lot of opportunities to develop many projects. So we have lined up some projects also for this particular masterclass. We'll go through with those projects right from the scratch. We'll try to build some of the models. Maybe we'll try to complete the masterclass working with working with object detections or other part of areas where computer vision can be applied. Okay, so let's start with computer vision first. There are lot a lot being discussed on internet. If you'll find out some really good definitions basically on internet, you will find out first of all the definition being driven with Wikipedia, right? So this is what Wikipedia tells. Computer vision is an interdisciplinary scientific field that deals with how computers can gain high level understanding from digital images or videos. From a video or image, how can you extract the meaningful information is being told by Wikipedia, right? So let us understand some other facts also being told by other platforms also. There's a very good platform and one of the biggest for software industry, that is SAS. So it tells computer vision is a field of artificial intelligence that trains computer to interpret and understand the visual world, right? So again the same definition but in different context, right? So it tells it's a field of artificial intelligence. However, computer vision can be applied in many different fields where computer vision where artificial intelligence is not a part of picture, right? Let's talk about the other definition being told by Adobe, right? It tells computer vision is a field of computer science that focuses on creating digital systems that can process, analyze, and make sense of visual inputs, right? Again, same definition, but in different words. Let's talk about Microsoft. It tells extracting rich information from images or videos. Like Microsoft has built up a product called OCR, and that OCR is optical character recognition. Means like nowadays, suppose you have written something from your hand, right? Nowadays, writing pads are coming up. Suppose you are writing down something on writing pad, digital writing pad, right? Maybe you have written in your notebook also, right, from your handwriting itself. While clicking a picture, it can convert that particular text which you have written from your from your handwriting into digital form, right? It can be copied. First of all, it should be recognizing the entire context of your handwriting, and then it should convert that into digital notebook, right? Maybe a PDF, which physical entire documentation which was available since centuries, right? It could be converted back into digital system, and that is the purpose of this OCR. Maybe if you can, if you want to use this OCR for handwriting recognition, maybe your signature authentication, right? So OCR can be applied over there. So Microsoft has developed this particular product, and that's why it tells the definition of computer vision is something to extract the rich information from images or videos. Likewise, IBM has said that computer vision is a field of artificial intelligence that enables computers and systems to derive meaningful information from digital inputs, right? So somehow all these definitions are telling, or the meaning of all these portals or different website or companies are almost same, right? But in layman language, what you can tell is whatever is the purpose of your eyes is there in the human body, right, which captures around 83% of the information. Similarly, for computer, to be smart enough to take its own decisions, right, it should have a lot of data, right? It should capture a lot of data, the real time data, and that should cover 83%, like the human body is covering from eyes, so it should be an eye for an AI. So computer vision will give you a liberty, or it gives us the opportunities to provide an eye for artificial intelligence. This is one of the simple definition or simple, layman language that you can actually call the computer vision is to. Okay, so let's try to understand what are the use cases that we have with computer vision working in artificial intelligence. If we'll apply computer vision for artificial intelligence, however, computer vision is totally a separate study. It's totally a separate field which can be applied to many different fields as per my understanding. And right now we are talking about computer vision to work with artificial intelligence, right? Okay, so there are fields like augmented reality, where augmentation of images, working with various objects, like nowadays you might have seen while clicking some images, right, in your camera, in your mobile camera, right, some filters are coming up, some images are coming up, maybe on your face, some cat face or some augmented faces used to be coming up, some augmentation of real environment will be coming up. So augmented reality has one of the great purpose to solve with computer vision. Another field like augmented reality, we have virtual reality. I would come to you for asking the question also, right, at the end. So whatever is your question is would be there in your mind related to any particular topic which I am covering right now. Please try to write in the chat box so that I'll go through with your chat in the end, and I'll just cover every single doubt if you have related to this particular topic and in going through with this masterclass. So virtual reality, where once suppose I am the human being, the real person in real environment is standing somewhere, right, and I want to create the same scenario, right, virtually. Suppose I'm maybe I'm right now available, or I'm going for a particular ride right now, right, for Himalayas, maybe for beaches, for any happening places, right. So all such scenarios which you are actually imagining, right, which you are actually available right now, if you can create that entire environment virtually, so that actually gives you another field of study that is called as virtual reality. And there are n number of products which have been made on virtual reality. There are VR headsets, right, in gaming applications. There's a lot, a lot coming on this particular field itself, which is virtual reality. So virtual reality has a requirement of computer vision to work with inside, developing a lot of products basically. Then let's talk about object recognitions. So there are millions of objects, maybe million or billions of objects available in the world. So to recognize them with your computer vision, maybe computers should have one camera or some specific laser system, maybe any other technology through which it should actually gather the information about that object, and it should recognize it. It does not matter whether you are talking about the camera only. Camera is not about vision, right? We are talking about images, we are talking about videos, but it's not through cameras only. There could be any like n number of technology basically with which you can actually capture images or uh, videos on real time, right? So camera is one of them. So why any method by which you can capture the information, if you want to actually talk about, or you want to actually recognize that particular object, right? So that comes under object recognition, which is one of the great application of computer vision is to. Then human posture recognition. Suppose you are standing, you are sitting, you are eating, right? So every single posture, every single activity of yours should be captured, right? Suppose we want to make an application for IT industry, we have some cameras, right? We are placing those cameras on every single cubicle, office, and we want to actually monitor the activities done by an employee. Similarly, in a classroom, we want to capture the activities done by students, right? Suppose we want to capture the activities of a child, basically, while he is in a study room, what he is doing, he is sleeping, he is studying, how much time he actually devotes to a study. So there are a number of application for human posture recognitions, right? Then medical field, there are millions of products which are actually required to develop a lot of applications through this computer vision, which you can start with MRI scanning, maybe X-rays, right? Maybe ultrasounds, right? So all these pictures which are coming up are detecting a lot of information from those scanning mechanism, right? Maybe your fingerprint scanning, retina scanning, right? So there are n number of applications in this medical field which are actually governed with this computer vision. Then OCR, which we have already discussed, related with Microsoft product, which is optical character recognition, maybe for handwriting recognition, your number plate, car number plate detection automatically. Suppose we are actually capturing from the road for a lot of vehicles, whether the vehicles are coming with high speed, right? They are crossing the red lights, right? So we want to capture the cars, and automatically we want to detect the car number plate, right? So there are a number of applications which are available using OCR as well. Okay, driverless cars, who who doesn't know about these things? So driverless car can only be imagined just because of the computer vision uh, uh, field applied to this driverless car. And Google, maybe Tesla, maybe many other people, many other organizations are working right now in these areas to develop driverless cars, right? Or self-driving cars. Then in agriculture, right, sports analytics, facial recognitions, surveillance systems, security systems, you can say, right, through drones, through maybe some laser mechanism systems. There are n number of surveillance system which has been developed, right? Taiwan, maybe Israel, right? These are the countries which are developing surveillance system. The record breaking surveillance system right now, and they have very good technology implementations inside those surveillance system, under which computer vision also comes into picture. Okay, now let's talk about the working concept of computer vision in this area of artificial intelligence development, right? So let's take a very very simple example. How let us compare human brain with the computer first. So how do we see any particular thing? Suppose there is a picture where there is a bowl where lot of different fruits are placed, right? They may be apple, maybe orange, right? Banana or something like this, right? So these fruits are placed inside a bowl, right? So what do we want to capture? There are two different people. One may capture, okay, there's a bowl, covering a lot of fruits inside, right? When having lots of fruit inside, maybe the another person is capturing, he will be thinking, okay, there are three apple, there are four bananas, there are three orange, right? Like that. And there is a bowl of black color. So it depends whether how much information do you want to extract from this single image. Maybe the table, this bowl is upon is actually put it upon this table. The table color is green, maybe the background color is white, right? So there could be n number of information which somebody wants to capture. So if you are here and you are actually you are actually watching this image, so how much information do you want to extract? That will be the outcome of this particular you know uh, uh, entire processing through this image to outcome. So now outcome is just very small, images, somewhat very big, which has been captured by an eye. Through eye, there are a number of connections here. I'm not going inside the connection. There are dendrites, there are a number of neurons, neural network, right? And there are interconnections also. Then this information will be fed to that particular part. Ultimately, final goal is to get the extracting information. And now we have extracted. There is a bowl, oranges, maybe bananas, lemons, peaches, something like that. Okay, right? So this is how we have got the human vision. Now let's talk about computer vision. There is a computer. Now one webcam or any sensing device. Now we are not talking about this sensing device as one of the camera only. It could be anything. So one sensing device is there, right, which is actually getting the input in terms of image or in terms of file. In terms of file, so any file, maybe JPG file or maybe PDF file, maybe Excel sheet, anything, right? So this is a file which has been given as an input to this particular sensing device. The sensing device is giving its its information, or maybe converted information from this file to a sensible input to this computer. This computer is actually having some algorithms inside, maybe computer vision algorithms or artificial intelligence algorithms, machine learning algorithms, deep learning algorithms, maybe simple computer algorithms, right? Sorting algorithms, right? So it may have any algorithm through which finally same algorithm which was working inside this brain also for the human being, right? So one algorithm which is working behind this interpretation. So it will interpret the information from this file, and finally it will tell the output. So somehow it is a replica. To computer vision is working for your replica, to develop a replica, so that the information which was captured by a human brain should be captured here with the computer as well, right? So final information from both the ends are same. Okay, final information from both the ends are same, and this is how it works. So now you should now you got it, right? So for interpreting the information, this input image is same. Maybe for sensing device you can use right now a camera. So this is not a big deal. Now the big deal is this particular algorithm. If you understand this algorithm, then only you will be able to extract the information from this input image to an output, right? That is coming with the final outcome of few four or three four values. Okay, so let's talk about these kind of algorithms then, right? So what type of algorithms are being used for computer vision to extract the right meaningful information? Okay, so these algorithms generally, maybe you can have machine learning algorithms or deep learning algorithms. So generally computer vision is working under or with deep learning much, because in computer vision you have lot of information, lot of images, right? And while working with a huge amount of data, machine learning actually does not allow you to give quite accurate result, because machine learning works with less amount of data to operate and work with those data to get a kind of accuracy level. So if you want to go through with deep understanding, deep study of an image, so you should go with deep learning part, right? So machine learning, deep learning has little difference while working behind to extract the right information. If you want some deep level understanding, some deep information, so you would require some more amount of time compared to machine learning. So machine learning is somewhat takes lesser amount of time compared to deep learning, right, for extracting the information. So generally, if let's talk about two students, right, just to let you know what is machine learning and what is deep learning. Let us talk about two students. One who study throughout a semester, one who is actually going through with every single topic each day, right? Every day he's studying about one of the topic for every single subject, right? So every day he is studying something, and then at the end of this semester he is going through with the exams. On the other side, we have another student who is actually just studying for 3-4 days prior to the examination, which we call as last night fight, something like that, right? So now you can understand, maybe the second student can get 70% marks, however the first one is just getting 73 75% mark. The difference between both of them getting the getting the marks is quite less, maybe 5% difference is only there, right? But the main thing is that 5% difference will matter a lot. If you will talk about self driving car, what if there is an accuracy difference of 5%? So one car has 95% of accuracy and another has 100% of accuracy, right? Now think about it. With 95% of accuracy, every out of every 100 situations, 5 situation would be bad, maybe it could be an accident, right? So 5% here in terms of accuracy matters a lot. However, 5% difference of an exam result or maybe marks difference does not matter much. So that's why deep learning gives you quite accurate result compared to machine learning part while working with computer vision. Okay, so let's understand how this computer vision can be linked with deep learning. So in deep learning we have neural networks. And there are various neural networks which are available. We start with artificial neural networks. There are various categories do we have. Then we have convolutional neural network, we have recurrent neural network, right? So there are multiple form of networks which we have available. Generally for computer vision, CNN used to be in use, right? CNN generally be used, right? CNN means convolutional neural networks. So CNN has its own functionalities. We are not going today with neural networks to discuss much in details. But yes, in neural network we have this kind of mechanism where we have input neurons, we have hidden layer neurons, right? We have output neurons, and all these neurons are interlinked. Those neurons are interlinked. So input neurons are linked with hidden neurons, hidden layer neurons are linked with another hidden layer neurons, and finally there could be n number of hidden layers, right? N number of hidden layers. Then those are connected with the output neurons. Suppose if these are the neurons which are actually linked together for input layer, then it is with it will be linked with the hidden layers. Hidden layer would be linked with the another hidden layers, and finally you will get the outcome. Outcome could be a kind of recognition. So the purpose here from input image to get the outcome here, or outputs basically, right? The purpose is actually to reduce the the amount of information that you had in input. Suppose there are millions of images you have, like talk about Facebook, right? So you might have uploaded hundreds of images on your account. Likewise, millions of users are uploading millions of pictures daily, right? So millions of pictures means, like, you can understand there could be maybe terabyte, or terabyte of information is going to be uploaded daily and daily on Facebook, and they want some insights of those particular images which have been uploaded by users. Okay, think about it. Some algorithms to be made on those images which are being uploaded by different users throughout the world. Automatically it should be done on server, right? So to reduce the amount of information from terabyte to maybe megabyte, or maybe gigabyte or GB or in MB, right? So this process actually helps you. Now from TB to or maybe petabyte, PT to MBs, right? To reduce your amount of information, you have CNN. And if you link this CNN with artificial neural networks, right, it gives you the recognition part of those kind of images, the activity that actually you are recognizing, right? Maybe you are recognizing whether any images, any image out of those millions of images which are being uploaded by users are some maybe unethical. Those are not good, right? Maybe some killing images are there, some disturbing images are there, right? So automatically those images should be deleted from the server, and this is what Facebook wants to do. If you on the other hand are working in a company and wants to do the same kind of analysis, right? Now you want to analyze the information from a user perspective. Nowadays everybody is learning digitally, right? But we don't know whether what is the engagement cycle, what is the engagement level of a student right now. Suppose suppose while going through the digital learning system, your camera is on and we want to capture your images, right? After this session, right, automatically there should be an algorithm which should tell, okay, this student, maybe name the student name is Rahul was attentive in the class with 80% of 80% of attentiveness, maybe 85%, 87%, somebody was just 30%. So can we actually go through with such kind of products to develop? I'm sure these they could be in high in demand in next couple of years, right? So computer vision with deep learning has a lot of advantages while working with artificial intelligence or inside artificial intelligence, right? Okay, so there are lot of algorithms, like earlier we were discussing about the part of neural networks, or the let me go back once and the slide. Wait, right here in this computer we had lot of algorithms, right, which were working for recognizing or getting or extracting some information from this image basically, right? Similarly, we have lot of algorithms for object detections, and there are models. Either you can call them as models after 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 completing a particular task through the algorithms, right, based on a particular set of inputs, right? So we'll see about models later on also. But now there are some standard algorithms which are working behind for object detections. Okay, so let us talk about few of them. So here is the list for the comparisons for the accuracies between those algorithms. So what are the algorithms? We have faster RCNN. So again, CNN is there. Inside CNN, there are n number of other n number of other categorizations available, and one of them is faster RCNN, which has, for one specific domain, it has accuracy level, or it has accuracy of 70% somehow. Okay, then we have RFCNN, and these algorithms are working since maybe 2000, right? Since 21st century, these algorithms are being developed and continuously updated. Okay, then we have got RFCNN. Some researchers throughout the world from different institutes, right, are working behind these algorithms. Some open source communities are working behind them to update, right? So RFCNN, SSD models have different you know uh, categorization inside. Once again, SSD at the rate of 300, SSD at the rate of 512. And what are the meaning of these things? At the rate of 300 or 512, they have different meaning. I'll tell you later on what are these meanings all about. Okay, then SSD 512 strict. Here we have got 78% accuracy with this. Okay, the maximum from the SSD. Then very good model right now working in the market, and many organizations are using right now, right? And that for object detection specifically, and that is YOLO. That is YOLO. Okay, so YOLO is one of the finest algorithm, one of the fastest algorithm working behind object detections. Okay, so YOLO at the rate of 5444, YOLO at the rate of 288, right? All these segments are working for different accuracies, and for YOLO the maximum amount of accuracy is quite same as SSD also. So both of them can be used for object detections, right? And if we'll talk about the speed of detection, then I would say SSD at the rate of 512, and as YOLO at the rate of 544. Both of them are of same accuracy, and both provide same accuracies as well as working with the same amount of speed as well. Okay, Then let's talk about RFCNN with a lot of different updations. Recently RFCNN, right, it's working with maximum accuracy, and that you can actually achieve, that you can actually see, right, while you'll be working with these kind of models. I'll show you how does this, how does this a model actually work working behind these kind of object detections. Maybe computer vision uh, programming, working with maybe Python, maybe a lot of other programming languages as well, right? So I'll show you some of the models working for object detections also in this masterclass in continuation in next few minutes. Okay, so we'll go through with the project part as well. Okay, now look, now you can see this image where different types of objects are available. If you'll see inside this image, you can gather lots of information, like stop symbol is there, there's a sky, there are trees, there's a road, there are road markers, there's a building, right, there's a car crossing the road, right, from one side to another, there's a bicycle, there's a pole, right. So while looking to this scenario, this environment, you can actually gather lots of information. And while comparing with comparing your human vision with computer vision, similar information should be captured. This is the final end and aim with this computer vision. If this computer can capture the same amount of information like we are capturing, this is what is the end result that we want. Okay, so like we had discussed the use cases in industries, we have in industrial automation, we have a great need of computer vision. Like you can see here, there's a conveyor belt, right, on which the products are going or coming up, and we are testing whether there's a defect in those products or not, right. Suppose there's a product here and which is coming up, we want to detect the shape, we want to detect the area, we want to detect the weight, we want to check whether there is a defect in this particular product or not, and also we want to count, whether how many products are coming up on this conveyor belt, so that we can get the production, or we can get to know the production outcome from this industry as well. Okay, this is what can be solved out through this computer vision. Now we can talk about the object recognitions in this environment, where there are people, somebody is coming from this bicycle from this side, and there's a car, maybe this is the road, this is the scenario, right. So if this information can be captured, it's a part of object recognition, which is one of the great need right now. Okay, activity recognition, suppose here there's a brain, there's a person, and a camera is there which is capturing his face. After computer vision algorithms, this algorithm is telling, okay, this person is recognized in our database, so it can get enter into this. So now let's talk about whether how is how is he expressing right now. Okay, whether he is nervous, he's smiling. So after getting the image of his face, finally we are working parallel with his his expressions also, what he is wearing, what kind of product, what kind of product or maybe brand he is wearing. So he is wearing maybe a good brand clothes, right. So this along with the face, the other parameters or these activities are being captured with this camera or some other sensing material or sensing devices, and these inputs are going to this particular computer. Yeah, I hope if you remember, like we have discussed till now, the application which we have seen, there are a lot of other applications which we have discussed about: industrial automation, object recognitions, activity recognitions, medical, right. In medical we have a lot of other applications, agriculture, self-driving cars, right. Then human pose estimation in military, faking faces, and lot of other use cases also, right. So let us talk about the challenges. So I told the one which I was discussing when this internet goes off, right. So it was like, uh, when somebody used to watch something, right? I'm talking about human versus computer vision. Human versus computer vision, right? So as a human, you used to see a particular image and used to extract a lot of information. So that extraction part is happening because of your brain. So till now we are not sure, 100% sure, whether we have actually replica of a human brain, the kind of algorithm that is working inside the human brain exactly captured with computer vision algorithms also, or not till now, right? So we're not 100% sure whether the actual replica of human brain is captured mathematically as an algorithm till now or not, right? So that is why it's a huge challenge that we have, or that we are facing in computer vision. So accuracy because of that is not working properly. So if you'll see here in computer vision, if computer will see this image, it will just focus upon one of the object. However, there are a lot of other objects or information which are available. So how is this cat sitting? Maybe what is the surface, what is the background, where this cat is looking at, right? And how is this expression, what does this cat wants to do, right? Whether she will be jumping or not, the future estimation of this particular activity. Similarly, this was with one single object only in left side. If we'll have multiple objects, then it's a huge difficulty that we are facing right now with respect to computer vision, right? These are the challenges, right? So what are the background? Again, there are multiple objects. What are the future estimations, future actions at estimation of these objects that we have? So lot of opportunities are there, within this computer vision area, where we can work to actually identify these kind of missing information that as a human we capture, but as a computer vision, computer doesn't capture, right? So these are the real challenges. And also, as a human, we all capture the information very fastly, right? So we are actually watching a lot of things in real time. And what happens, we used to capture the information also, uh, extract the information in the real time itself as a human, but computer doesn't do it. It requires some lot of time, right? It requires some time basically to actually capture the information, then working with the algorithm, and then convert that information into some meaningful information behind. So the configuration of laptop, like you have 8 GB of RAM, 16 GB of RAM, something like this. So these configuration will matter a lot in computer, right? So these are also the challenges, the other challenges that computer vision faces right now. Okay, so these are the challenges that we have seen, comparison with the human vision. Okay, and here, if there are challenges, these are the challenges, then these are the area or the scope of innovations, right? So challenges, wherever there are great challenges, is a great opportunity of doing something big. So think in this domain, in that particular challenging domain, in such a way that if you can develop something good, if you can develop some good algorithms, right, then surely it can become something reasonably good, for the upcoming products, based on your own research, or based on your own algorithm which you will make. Okay, yeah. So let's talk about the projects that we have started for this masterclass, that is object recognition or object detections. So here you can see, if this person, if there are two person, there's a lady and there's a male here, they're coming up towards this camera, right? So if they are little at a distance, so from the camera perspective we are talking about. So the camera is telling this is, or the computer vision is telling this is a person. Okay, this is a person. However, the a woman is here and it's closer to this camera, and now because the vision is clear, now you are 100% sure, the computer is 100% sure this person is a human being, a human, sorry, a person is a woman, right? So this woman is closer to the camera, and that's why the accuracy in taking the decisions towards this particular image is quite good comparing with this particular person. Okay, likewise to this car also, if this car will be coming closer to the camera, so somehow the camera can tell of which company this car is, right? What is the model of this car, and what is the number plate, who is the owner of this car, the information about this car as well. Maybe it's a diesel or petrol or EV vehicle. Okay, so what is the segment of this car also, maybe the four wheeler, the eight wheelers or something like that. Okay, so more information towards these kind of objects which we can capture, right? So these are the uh, areas of innovation that we have. Okay, the another project that we have for today is AI based security authentication. Here you can work on facial expressions, maybe the elements which actually gives more information of your facial expressions, the eyes, nose, mouth, right, the forehead, maybe the eyebrows, right, the uh, while doing some expressions, right, maybe your teeth, right, while you are smiling, just laughing or smiling, there is a difference between some these two parameters also. So you want to predict whether a person is smiling or laughing, right? So there'll be a lot of changes in these kind of elements of your eyes, maybe nose or mouth, right? So we need to check, we need to work on these projects today, and let's see whether can we extract some good information from it. Okay, yeah. So face marking, what it does, so we are having Python code itself, right? So we are working inside the Python programming for the projects. So I'll provide you these codes also, don't worry about it, right? I'll provide you these code, just you need to install some basic libraries. Here we have imutils, right? For image utilities, right? We have time library, we have dlib. These are very specific small libraries that you don't need a specific configuration basically, right? And computer vision library for Python, that is cv2. Okay, or you can say opencv, open source computer vision library, right? So daily provides you to actually deal with the models that you have. So here we have shape predictor. So from your face it will predict some face landmarks. Okay, so here we have two models. Let me show you, we have two models. One is for 5 points and one is for 68 points. So let me show you first of all what will be the difference between 68 points and 5 points face landmarks. Okay, so that you can use both of them for detecting something good or maybe extracting some good information. Okay, and the rest part of this particular code I'll just explain you one by one. Okay, we'll go through with the entire code, don't worry about it. I'll just explain each and every single line, so that you can deal with the same project, and you can work on extracting some good information related to the image processing or computer vision. Okay, so let me run this code first. Yeah, so what it does, it used to capture these kind of points. It's capturing the entire face, and then eyes, these points, the nose, then mouth, right? And if I'm just rotating my face, or just changing my face into another directions, again these kind of points are relocating its positions, right? The positions from one place to another place. Okay, so let me show you, if I would change, let me stop this code, and let me change this with 5. Okay, let us check whether what kind of information will be available. Yeah, now it's clear. just check. Here we have I points, these 2 points, and just a point on my nose tip, right? Nose tip. This is how uh, you get the points. So how these points are going to help you out basically in this computer vision, right? Or for any specific use cases, right? So now if I'll close my eyes, I'll do some specific expressions, okay? So now the distance between this point and eyes, right? If I'll shrink my eyes like this or something in a different angle, so you would see the distance between these points are going to be changed. What if I can have 2 points, right? X1 y1 and x2 y2, these are the coordinates for these 2 points that I have, point number 1 and point number 5. So can we get a distance between both of these points? The formula that we have, okay, so that the formula, let me just go back to the 68 point landmarking, okay. These are some standard codes. You need not to worry about these codes, right? I'll provide you these codes if you want, right? At the end of this session, I'll just provide you these code. Don't worry about it. So let me show you something how you can actually get the maximum outcome of it, right? Okay, suppose, yeah, this is a face, right? Here you have points. These are the eye points, and this is the nose tip point. Point number 1, 2, 3, 4, and 5, right? So this is what you have, x1 y1, and here you have x2 y2, right? So can you find out a distance here in between these 2 points? That can be d1, likewise d2, here you can have d3, right? Likewise you can have any n number of distances from these points, and right now we are talking about only 5 points. Right now we are talking about 5 points. If we can have 68 points, then surely we'll have more number of distances. So with 68 points there could be, suppose, n number of distances. What will happen with these distances? You can actually check how many distance d1 till dn, right? How many distances while doing some expression changes, right? While doing some changes in expressions, maybe you are smiling, you are laughing, you are normal, you are sad, right? You are sad, maybe n number of expressions. So with every single expressions, definitely these distances will be going to change. So you need to note down. There could be a table. You need not to do it through manually, right? You don't need to do it manually. Automatically your code, you need to write inside the code in such a way that all these distances d1 till dn for x expression, right, maybe x1 expression, these are the changes in distances, right? Likewise you will prepare another table for x2 expression, d1 to dn, these are the changes, right? So likewise for n number of expression, for maybe n number of expressions, there will be n number of tables, and these tables will be utilized. These tables will be utilized inside a program, computer program, right? In such a way that this program will identify the types of changes, the patterns that are going to change in one of the particular table with respect to another table. So if all these changes are happening in between d1 to dn with one specific pattern, suppose this pattern is something like this, then this would be smile, right? And there could be like this is your expression, right? Then there could be another expression like said. So overall what I'm telling you is, you need to work on the parameter that is distance, right? With respect to distance, right, you can actually work on expressions, right? So this is one of the program that we have seen. This was one of the program that we have seen. Okay, now let us check whether how does it work, right? How is working basically, and how it's capturing those 68 points. So we have captured, we have made a particular variable, that is vs. This vs will help us to capture some images through our webcam. Okay, so it will take 2 seconds of time while going ahead inside this program. While true means the program will be running continuously. Now vs.read, this function will capture one specific frame at a time. So the data, that frame will be going inside this frame. Now we are resizing this frame with 400 by 400 resolution. What does it mean? It means that the original size which was little big, we have resized that to a smaller resolution, so that processing should be little faster, right? Processing will be little faster. Now let us convert that RGB data or color, right, related to the models and accuracies basically, or the algorithm which are used for computer vision, faster RCNN, RFCNN, SSD or something like that. So I'm just going to use one of them, that is SSD, which I've told you one of the finest model or the algorithm which is based on computer vision for CNN, convolution neural network, right? So like I have already told you, there are a number of neural networks that have been prepared by different organizations, and people are using. Then let me take you through the entire course. Let me take you through the entire course. Like here we have these libraries, and one of the biggest library for data science working with Python is NumPy, right? Numerical Python. If you want to deal with the numerical data, right, in Python, there we have to use NumPy. I'm sure everybody is using it, including Google is using it, right? Google has developed a framework for deep learning for artificial intelligence, and that is TensorFlow. So TensorFlow is made up upon NumPy itself. Argument space, right, or argument parser is one of the area where you can deal with these kind of things. However, we are not going to use it much, right? We're not going to use it much because this particular library is used to deal with the command prompt or terminal or running time arguments to give on. So here we are using mobile, that model of model based on mobile net, the model based on mobile net SSD, right? Okay, so let us try to check what kind of outputs that we are going to get from this particular model. This model is good for these 20 objects, right? However, we are just going to work on one particular one. Right now I am only the person who is available. Let me check. I have mobile phone also. Let me check whether this mobile phone will be detected or not, right? So bus, car, cat, chair, cow, dining table, dog, horse, motorbike, person, potted plant, sheep, sofa, train, all these 20 different objects that can be captured through this particular model only, right? Nowadays if you will see, YOLO and SSD has released the models, and those are available on internet. However, those are big, quite big also, right? Maybe in MBs, right? It's very small. That's why this model will be running very fast, right? And it is working just only for 20 parameters. If you need some more parameters for 80, 100 different parameters, so few more models are free of cost, open source, available on internet. You can download them, just replace them with this mobile net SSD, and you will get other parameters to be detected. Okay, so I'll provide you this code also, don't worry about it. Let me just try to run this code just to show you how will this code be running and what kind of outputs will be getting up. Okay, yeah, so it's telling that there's a person in front of a camera, and there's the accuracy of 99%. there's a confidence, you can say confidence, not accuracy, there's a confidence, right, of detecting that person inside that image is 99%, right? So now you, like you used to tell that person is coming, so you're confident enough whether the person is there or something else is there, right? So here this code is telling whether the person is in front of the camera, and it has a confidence of 99%, right? Let me show you. This is how I am coming up, right? Yeah, right. So it's not detecting anything else. Let me take my mobile phone in front of it. However, mobile phone was not a part of this. uh, what else was this? Let me see. Bottle. Yeah, let me take bottle basically. I'm sure it will be detected. Give me a minute. Akshay. Yeah, if it is work, yeah, it's working now. Let me show you another code, and I'll just explain you everything here then, right? So in this code, we are actually trying to work on and try to achieve that whether it will recognize my face or not. So this is what I have captured one of my click a couple of months back, right? So this is what I have another picture of one of my student, right? That is Amit, right? So we have two images, right? So we have got this code. I have taken both of these images as my database, right? So these are the database. These are two images. So if my running or real-time image, which has been captured from a camera just now, if will be uh, compared, or will be, compared and maybe, captured in, between these two images only, right? If it will be matched with any of these two images, then we'll get the answer of that particular image, right? So what we have done here, name ind means either Saur or Amit, any one of them will be coming here. So Saur is recognized, Amit is recognized. So whoever so will be available in front of camera, right? If that is either Amit or Saurav, that name will be coming, and then this sentence is recognized will be coming up. Okay. So if we can add or load some more images, suppose there are 10 people and we want to work on, maybe security purpose. For security purpose, we want to authenticate a person at an entry gate, right? We want to authenticate a person whether the right entry is there or not for a person, okay? Whether the person is allowed to come in or not, right? So in that respect, so we can add some more images, and this code can be utilized for authentication purpose, right? So if it will be working fine, this final code, if could be deployed on website or in any hardware like Raspberry Pi or Jetson or any other hardware, right? Or in a computer. So if that particular deployment of this code would be done, then that product will be called as AI product, artificial intelligence product. Okay. So AI based security authentication, if you want to work with that, you need to go through with this kind of application ahead, right? Let me try to run this code now.